Kia ora Year 12. This question is a really nice old excellence question that makes you remember some of the basics that we've looked at. We have to remember that to solve problems like this, we often have to equate real and imaginary coefficients. So what I've got here is z is equal to this, and we have to figure out what x and y are if this is true. So I'm going to start by just substituting in the x plus iy. Because I'm doing an excellence video, I'm going to go straight into rationalizing, so multiplying by the conjugate. So we've got 1 over x plus iy. So straight away I'll go times this and whack in some brackets. There we go. So that's the first bit, plus 2 over the conjugate, which gives me x minus iy. Rationalizing the denominator gives me that. And that equals 1 plus I. So you can see the really nice thing here is that straight away I've got a common denominator, and we can chuck those two things together. We'll get x squared plus y squared. Right, remember I squared is -1, blah, blah, blah. And then in the numerator, what do we have? Well, we have x minus iy plus 2x plus 2yi equals 1 plus I. Our goal is to figure out the values of x and y. So here we've got 3x plus, so I've got minus iy here, and plus 2iy. So it's going to be plus yi over x squared plus y squared is equal to 1 plus I. Now I can cross multiply at this point, which is what I did, which was just a bit stupid and made more work. So when you look at it slowly, you see that here you've got your real bit. Over here you've got 3x over x squared plus y squared plus y over x squared plus y squared I equals 1 plus I. So what can we say now? Well, we've got 3x over x squared plus y squared equals 1, and we've got y over x squared plus y squared is also equal to 1. That means that 3x over x squared plus y squared equals y over that, giving me 3x is equal to y. So we're going to take this and we're going to substitute in y into here and solve. So 3x over x squared plus 3x all squared equals 1, giving me 3x equals 10x squared. Now don't divide through by x, just set it equal to 0. Something very strange going on here, but I quite like it. There we are. So we get 0 equals that. So 0 equals x into 10x minus 3, giving me a value for x. So x equals 0, or x equals 3/10. Now, if x equals 0, then y equals 0, in which case our complex number is equal to 0 plus 0i, which would be stupid. Not a very mathematical reason, but I'm sure they told us at the start that x and y were positive. I'll just check. No, they didn't. Okay, but so there's actually two solutions, I guess. One is the one where z is equal to that, but the more interesting one is that x is equal to 3/10, so y is equal to 3x, which is going to be 9/10. So there you go. It's just a nice example. Yeah, it's just a really nice example of a question where it looks like you can't get your x and y squared out, but all you've got to do is remember that you're equating your real and your imaginary parts. Thanks for watching. I think that's all for today. Email me if there are any particular questions that you want me to go over tomorrow.